but the lectures are easy, generally speaking, very easy. And then we break 15 minutes for the first tutorial. We take a lunch break and then we come back and do the second tutorial. The first and second tutorial are very same, but one of them will be done here. The other one you have to actually go and scout and find something outside. Okay, and then we can all come back here and we can see what you have found. All right, but I'll talk about the tutorials when in the afternoon. But right now we're going to continue the water concepts. Right, yesterday we talked about water. We looked at water molecule, the angle of the water, right, and then yeah, so pores, yeah, that's the substrates. But then also we talked about water, right, later on, right, water chapter. But today it's more on the applied side, right. We're going to talk about irrigation. What is the right way to irrigate plants? What are the different ways of irrigation? What are the advantages and disadvantages? How do you know when to irrigate? How much to irrigate? Those are the kind of questions we're going to address today. Whatever I'm talking today is for those soilless substrates. How do you irrigate soilless substrates? Hydroponics is totally different. Okay, we have a separate lecture on hydroponics, and we have different methods of adding water to plants in hydroponics, and then I'll talk about it in the hydroponics lecture. But today's irrigation is for soilless substrates. Okay, all right. I don't know what's going on. Give me a second. Okay, probably I'll do like this. Okay, and then let's see. Can you all see from there, or is it too small? If you want to come forward, otherwise maybe. Huh? I used to use my USB drive, and then they pulled it up today, so I can do that, but I just don't want to waste time. But if you can't see, I will do that. Can you see it? No, you can't see from there. Can you see from there? No, you can't. You already have it. Yesterday they sent you. Can you open on your phones or on your laptops, whatever it is, just in case? But come closer, anyways. Now that material that you got is like a sort of like a small booklet for you, all right, kind of like a guidance you can always use in the future too. But any case, just give me 1 minute. This is too uncomfortable. I'm going to use my USB drive where I can get bigger slides. Yeah, this is not the right way. I tried. That's what we were before. You see, so then what happens is it shows up, and I'm trying to move. Yeah, it is moving, right? Okay. So on your okay, then let's stay here. There are two slides actually here, and my original presentation. This is one slide, and this is another slide. So a little bit too much on one slide, but if you're okay, we'll go with it. That's fine. All right. So let's start here up at the top. Maybe for the next presentation, I'll use this. All right. So there are two methods of irrigation. Again, like I said, this is irrigating soilless substrates, not hydroponics at this point. Hydroponics is totally different story. For soilless substrates, you have two types of irrigation. One is called overhead irrigation, which is probably what you're more familiar with. And the other one is called sub-irrigation. Two types, overhead, sub-irrigation. Overhead irrigation is top down. You add water on the top of the substrate, water goes down out of the pot. Overhead, okay, top down. Sub-irrigation is bottom up. Okay, you add water at the bottom, the water wicks up, goes up through the pores, and then there is no wastage or leaching. And we'll talk those two in very detail. But those are the two standard methods of irrigation we follow in greenhouses for plants grown in soilless substrates. So you can grow them in peat, coir, you can grow them in pots, whatever it is. This is how we irrigate. Those are the two standard methods. Okay, I'm going to give you some examples for overhead irrigation, hand watering, simple, right? You probably have a hose, what we call hose, or a shower or a sprinkler. You just shower on top of the plants like that. That's hand watering. You have the sprinkler system that comes on and adds water, right? So you can have plants in 2 furrows, and then you have a sprinkler going in the middle, water sprinkles out. Very simple, right? That's sprinkler system. You have boom irrigation. You see this picture here? So what happens is, this is one of commercial greenhouses. In every 1 acre, what they do is they will have a boom at the end of the greenhouse. The boom moves from one end to the other end. Okay, the boom is moving, and on top of the boom you have sprinklers. So as the boom is moving and the sprinklers are on, all the plants below get water. Do you see here, right there? I think we should, let me see. Do you see now that boom right there? So there is a boom here, and it's spraying water. Do you see that? It's spraying water. That's called boom irrigation, and we use boom irrigation for bigger greenhouses where you can't go and manually hand water that. And then why don't you give me 2 minutes? I wanted to, let's do this, okay? This is a little bit inconvenient. Just give me 2 minutes. Okay. So this is what we talked, right? So that is boom irrigation, and then we have the drip irrigation, which you're all familiar probably with, and we'll talk about drip irrigation and how it is done, things like that. But then when you come to sub irrigation, remember it's bottom up, right? We have 2 methods, ebb and flow and flooded flows, and I'll describe about them, both of them. But this picture should tell you how the parts get water. Okay, goes upwards. Here, water goes downwards. That's a big difference. All right. So let's talk about overhead irrigation. What are the advantages and disadvantages, pros and cons, right? So here you see hand watering. They are just in a small greenhouse. They have some plants in pots, and they are just watering with a hose, with a shower can. Here is a boom irrigation I've talked about, and here are some sprinklers. These are the sprinklers. Sprinklers can be on the ground. Sprinklers can be also at the top. Okay. In this example, these are the sprinklers. These are the sprinklers. The plants are at the bottom, so they are just spraying water. Okay. All of them are top down. Whatever that method is, water is being added on top of the plants or on top of the substrate. That's a major commonality. Okay, so what are the advantages and what are the disadvantages? The advantages is it's less expensive. It's less expensive, okay? But there are many disadvantages, many disadvantages. The number one disadvantage is waste of water. Look at this picture. This person is watering. How much of that water do you think is actually falling in the pot, and how much is actually falling outside of the pot? There's a lot of water that falls actually outside of the pot, and all of that water simply runs down, goes away. So there's a lot of wastage, number one, in overhead irrigation. Now if you have a soil and you're adding, let's say you have a raised bed or something where you have plants, and then you want to add by a sprinkler, by a shower like this, maybe you are improving the efficiency there, because now the entire soil is getting wet. But then again, the root system may not be there in the entire soil at the time, right? So that is one catch there. This major disadvantage is when you are in greenhouses, in greenhouse crop production, we don't simply add plain tap water. Almost always that water has got what? Fertilizer dissolved in it. So the term for that is not irrigation. The term for it is fertigation, right? Because we apply already Soluble fertilizer is there in that. So now you are taking this fertilizer water and you are applying on top of the plants. Those fertilizer droplets, those droplets will remain on the leaf. The water will evaporate after some time, but that fertilizer salts will still stay on the leaf, right? You are showering like this, the droplets will fall on the leaves. After some time, the water droplet will evaporate, but the salt in that water droplet will be there. It's not going anywhere, and that can cause some harm to the leaves. That concentrated salts can cause spots, browning, things like that. Sometimes, some death of the leaf tissue, things like that. So that's one other problem with that. So when you are adding from top. And we all know that when you add water on top of the plants, sometimes that kind of favors insect and pathogen, mostly diseases, mostly fungal and bacterial diseases. They kind of go up because it's humid. You're adding plants, the water always remains on the leaf for a long time, and during that time, you are actually, causing and creating a congenial environment for bacteria and fungi to grow. So that's another problem. So bacterial problems, fertilizer accumulation on top of the foliage. If it is like tomato plants that you are going to harvest and then you are spraying water on that, now that fertilizer is on top of the fruit also that will consume, right? So that's another problem. Wastage is another problem. Okay, all these things are important. There is another problem with overhead irrigation that I'm not showing up there, but let's take a part. In that part you have a substrate and there is some fertilizer already inside that substrate. When you are adding top down, what is that water doing, that new water doing? Let's say if it is not fertilizer water, you are simply adding plain water. What is that water doing? It is pushing down, right, down the pot and getting out of the bottom. It's pushing down the pot and it's going out of the bottom, right? As it is pushing down, it is taking all that fertilizer in the substrate with it, and then that fertilizer is getting out. So this is called leaching. The term for that is leaching, and the leaching losses are high in the overhead irrigation. You are actually, if you are adding too much of water just to make sure that all my pots are thoroughly wetted, sometimes you may be adding too much of water, and when you do that, some of those fertilizer that's already there in the substrate, it will get out of the pot, you're losing it basically. That's another disadvantage. So leaching losses, fertilizer accumulation on the leaves and scorching the leaves, bacterial diseases, fungal diseases, wastage of water, all these are disadvantages with overhead irrigation. The only advantage is it is some of them, not all of them, some of them like hand watering is very less expensive, cheap. But if you are going with boom irrigation, sprinklers, it can also cost. Okay, so there are a lot of disadvantages with overhead irrigation, and that is the reason why in many of the Western countries, especially in the Europe, and also some of the greenhouses I've seen in the United States, they use sub irrigation. There are many benefits of sub irrigation, but I think we'll get to that sub irrigation in a minute. I want to spend a little bit more time on one of the most efficient methods of overhead irrigation. I said water loss is a big deal, right? But there is one method of overhead irrigation that reduces wastage. What is that one? Yeah, let's look at the drip irrigation. What are the important things you need to keep in mind when you are setting up a drip irrigation system? So here is a drip irrigation system. These plants are lettuce plants. It's actually from one of our greenhouses, if I'm not mistaken. But let's start here. So in drip irrigation system, you will have a source of water. It could be a tap, something in the greenhouse. Okay. To that, you will connect your first a tubing, what we call high density polyethylene, HDP tubing. It's usually black in color. It can even be a regular hose that you will use, but that is the main line for water. All right. So let's say this is our greenhouse. This is our greenhouse, and all these are benches, and we have pots arranged. So now we have to set up a drip system to each and every pot, right? So how do you do that? So you can do that multiple ways. So let's say you have your tap here, water tap here. From here I am going to run a long line, right, all the way to the end. This is a tube with at least 1.5 inch internal diameter, all right, a wider tube, and it could be a high density polyethylene, so it can hold some pressure. Okay, the tube is going all the way to the end. Right at the end, what I do is I have to close the tube to create the pressure. I have to close the tube. You have, caps that you can use to close it, or you can also bend the tube on the end and then put a sort of like a clamp or something that will hold it like that. But there are many ways you can do that, but you got to close it to create the pressure. So that's step one. Once you have created that, then I am going to now create laterals. I'm going to create laterals. These can be LDP, low density polyethylene tubing, could be 1/2 inch tubes. You don't want to really use really thick tubing here, and I'll tell you in a minute why, but you can use 1/2 inch black polyethylene tubes that go laterally. Maybe you can have a lateral for every 5 feet, okay, or maybe 10 feet, depending on the length of your greenhouse. So now we have laterals too, and these laterals should also be closed at the end with either a cap or a clamp. You bend it and put a clamp on it. So now you have, and then when you turn the water on, the water goes through the main HDPE, it also goes through the laterals. And as all of these get filled, you have created enough positive pressure inside these tubes, right? Now then, how do we get the water from the laterals to the parts? Here is where the step one comes. See, this is what we call a pressure, we call it a pressure compensated drip emitter. The word is important, pressure compensated. If you just buy regular emitters, drip emitters, the emitters look like this, okay? The emitter will look like this, a small thing. It's about that size, just that size, okay? You have to buy pressure compensated drip emitters. What the pressure compensated emitters do is, in this long lines, the HDPEs and the laterals, there is always a possibility that when you are running drip system, you lose pressure. When you lose water pressure, what happens is, at some points, you get a lot of water through the drip. At other points, you may not get sufficient amount of water. You want to make sure that your drip system is uniform. And one way to get there is to use these pressure compensated drip emitters. These compensate. What does compensate mean? Adjust. Kind of adjust for, if somewhere there is less pressure and somewhere there is more pressure, this kind of balance that a little bit. So your uniformity is actually improved. So make sure when you buy the packet of drip emitters, it says on top that they are pressure compensated drip emitters. That is number one characteristic of emitters. Number two, for emitters, you should also know flow rate. Every emitter has a flow rate, certain liters per hour. In the United States, we use gallons per hour, okay? But probably here in India, you will find on the packet, number one, is it pressure compensated drip emitter? Yes. Number two, what is the flow rate? Let's say 100 liters per hour. That's the flow rate, okay? Remember that. Those are the two things you need to know before you buy those emitters. Now, if you look at this emitter, it has got two ends, right? This end will be inserted into where? Into that lateral. So you get punches. They sell these punches. All you need to do is punch a hole. You can push it and make a hole. The whole diameter is actually smaller than that one, the diameter of the tube on this side. So you can actually snugly push it into that hole. But you got to punch holes wherever you want, and then you insert this emitter, that end, into that hole. Okay. Now that emitter is now inside the lateral, not the main one, but the laterals. Okay. And then on the other side of the emitter, this is what we call a capillary tube, or you can also call a flex tube. This is a very tiny, small. It's not even wider than that much diameter. It's like a pencil thickness, like your pen or a pencil. That's how thick it is. Oh yeah, there it is. You can see it. You see these capillaries. You can use one capillary per emitter, or you can buy what we call a manifold. A manifold can create 4 openings. That manifold is inserted here, and then you get 4 such openings. Okay, right? You see the adapters, tube adapters. You can get 4 openings, and you can connect 4 capillaries if you want to do that. And then water goes from capillaries through to this drip stake, and here is where you got a lot of options. The most common one used for pots are these drip stakes. The drip stake is simply inserted. You see this green color thing right there? A little bit of this green color, that's a drip stake. You push it into the substrate. The drip stake sprays water whenever the water comes through it. Now, what did I say? The flow rate is important, right? I gave you an example of what? 100 liters per minute. If I am using a manifold with 4 outlets, the expectation is that each outlet gets 25 liters per minute, because it's 100 liters, I'm sorry, 25 liters per hour. Okay, so 25 liters per hour is going to go through that particular capillary tube into that pot. 25 liters per hour. But let's say if you want to only add 1 liter per pot every day, you can easily do that. How do you do that? What do you adjust? So again, let me explain. This drip stake capacity is 100 liters per hour, but I put a manifold. The manifold has 4 outlets. So how much is flowing through each outlet? 25 liters per hour. But I don't want 25 liters in that pot. It's a small pot. I'll kill the plant. I only want to add 1 liter every day. 1 liter every day. How do I do that? Think simple. Think simple. Go ahead, explain, please.
There is a 100 liters per hour. So we let the timing of the test.
Right. So don't run the drip system for 1 hour. Run the drip system for what? 2 minutes, 5 minutes, does it? That's it. You get less water, right? Good answer. That's why you do that, right? So you have the control. But here is the most important thing. Before you use this drip system in parts, before you place parts, first set up the drip system like I described, with all the emitters, capillaries, however you want it, manifolds and everything. But let's say you have a greenhouse of this size. In this size of greenhouse, you know what I will do? I will take maybe 10 or 15 empty buckets, okay, or beakers, something like that, plastic buckets, and I will put them randomly, one over there, randomly distribute them. Put your drip emitters in there, empty ones, you know, these drip stakes right inside, and run your drip system for 5 minutes. And then go and measure the water. You can do 2 things there. First, you will know how much water is coming through. All these numbers, 25 liters, 100 liters, this is what the manufacturer is giving you. But there is no guarantee that that's exactly what is coming out. It will depend on your tubing, your laterals, how you design it, all of that, the pressure of water you are getting. So measure it first. Measure it in your own greenhouse, in your own location. And if you see that, okay, now for 5 minutes I am getting 3 liters, okay, I just need to add water for 1.5 minutes to get 1 liter. I got it. But also there is one more thing I wanted to measure. How uniform is water volume in all these buckets? In that bucket I am getting 5 liters. In this bucket I am getting 1 liter. There I am getting 3 liters. Then you have a problem. You did not do your drip system well. What's going on? Where is the pressure falling apart? Wherever you are getting a lot of water, that is where there is a lot of pressure. Where you are getting less amount of water, the pressure is dropping. So you may want to do something. What do you do then? Let's say over in that corner, that bucket has very little water. There is no water flowing there. Then the problem is not, maybe it is with the way you put the drip system, but most likely the problem is with the tap. The tap is not letting out enough pressure. So if that happens, instead of 1 main line, have 2 main lines. Run 1 main line for half of the greenhouse, the second main line for the second half of the greenhouse. Something like that. It's very simple. But measure and see how uniform it is across locations, because this is the fact. I will tell you one thing that is very, very important in greenhouse crop production is uniformity. all plants should be uniform in size. They should all mature at the same time. Then you get the maximum yield. By simply maintaining uniform crop production, I have seen personally 15 to 20% more yields can be achieved. Uniformity is affected by light, right? The transmission of light, we talked about it. Uniformity can be affected by greenhouse temperature. Uniformity now can be affected by the amount of water you are supplying, and with the water, the fertilizer you are supplying. All these factors affect uniformity. This is the reason why I'm giving all this information about how light affects growth, how you have to do, lighting, things like that. Same way for water too. Make sure you measure it at different positions. Be comfortable. Remember coefficient of variation, we talked about it in the first lecture tutorials. You need to know how much variability is there in different locations. You want to make sure that the variability is not more than 10-15%. That is pretty tight, pretty good. You can't achieve zero variability. There's no way in biology, in real world, you can achieve zero variability. There is going to be variability because environment changes, everything changes. But keep it minimum, 10 to 15%, then you are in a good shape. Okay? Does it make sense how to set up a drip system? All right? All these components. Okay. The most advantage of the drip system is it reduces irrigation, it increases irrigation application efficiency. There are many terms here. One of the terms is application efficiency. Let's compare drip system with sprinkler system. You know the common sprinkler, sprays water. Here is a drip system with a drip stake, adding water straight into the pot. What I'm saying is drip system has increased application efficiency. Application efficiency simply means if you let's say you add 100 liters of water to plants, to pots, how many liters are actually falling on top of the substrate? So let's say for drip system, it is almost 100%, right? All of this water is falling on top of the substrate. None of that water is falling away from the pot, right? On the ground. So it's almost close to 100%. But that's not the case with a sprinkler. If I put a sprinkler here, yes, there is water on the substrate, but a lot of water also falls away from the pots and gets wasted. That is application efficiency. Drip system increases application efficiency. And this is what in some countries like Israel, they do this in a much broader way. They will never use sprinklers there because they don't have water there. And maybe we may have to also start using in case if you want to use this drip system. Okay, remember that application efficient irrigation application efficiency is significantly enhanced. But what I wanted to really spend time is how to set up a drip system and what are the considerations you should keep in mind when you set up a drip system. Okay, is that simple enough? Do you follow that? Okay. All right. Now in
One question, sir. If we have irrigated 1,000 square meter polyhouse, what is the process? We are adding some water.
So please explain more. So you have 1,000 square meter greenhouse.
Yes, sir.
Okay.
We irrigated through drip irrigation.
You irrigate through drip irrigation. Okay.
So what type of process like we are adding some water, pressure motor for
Creating the pressure.
Irrigation.
Okay.
Is good method. I guess.
Well, you are adding the pump to create that positive pressure, right? So you get. But did you check these things like how much water is coming out of drip?
That is not beneficial for 1,000 square meter.
No. I'm just giving an example. You can probably have a big well, or in some situations what they do, they'll have a big tank, and in the tank they mix fertilizer also, and then they supply fertilizer water. You can do. It's just an example. Tap is just an example. Okay. You can do anything. That's the source of water. The source of water can be different from location to location. If you have a sort of like a 5-acre greenhouse, what will a tap do? Right? What will a tap do? Nothing. So you can use the source of water is up to you. It is your location. I'm trying to tell you what you need to consider when you set up your drip system. So if you have not used pressure compensated emitters, what you can do is next time, these drippers go bad. They are not always going to remain. Sometimes they get clogged, sometimes they don't work. But next replacement, whatever you do, make sure you buy pressure compensated drip emitters and make sure you know the flow rate through them. And then when you know the flow rate, when you don't have plants, also check for uniformity. Checking uniformity, checking the flow is so important with drip. Otherwise, you are plants, if you the one thing is when you are applying water by hand watering, that less water problem won't be there. There is a wastage problem, but at least you know you are applying a lot of water to parts. But when you get to the drip system, you are, if you don't apply sufficient amount of water, you are going to kill your plants. You will assume that all my plants are getting water automatically, but maybe not. Okay, so make sure you do that. I've also seen, in fact, we use this in our research. Instead of those drip stakes that spray water, we have tubes, round tubes. Okay, so let's say you have a big plant and you want to irrigate all around the plant, a big tomato plant or a big wine crop that requires a lot of water. But you want to apply water. You see that stake, what is it doing? It is spraying water, but it is spraying water on the substrate. Yes, there is no wastage, but it is spraying only at one location, isn't it? All the time. If you have a big part, water is always falling here, and then the water has to slowly, move inside the substrate. But even you can avoid that. You can buy small tubes, and these tubes have tiny drippers. So that capillary that I talked about, now that capillary is not connected to drip stake, but it is connected to this ring. You just connect it to the ring and you put the ring around the plant. And now you get water delivered at 10 different locations around the plant, and that's a lot more uniform. You can also do that. You don't have to buy drip stakes. All options are there. Okay, just look into, there's companies called NetFM, right? That's what you use in India common, right? But there are also many other companies you look into and see if what options you have. But again, simply don't rely on what the company is telling you. Get your own data. This is the number one thing for a greenhouse grower. They should not rely completely on outside information, because that outside information is based on some laboratory, some separate location, which is probably totally different from your location. Develop your own data. That's the most important thing. Okay? All right. Now, do you grow hanging baskets in greenhouses here? In floriculture, do you do? Okay. Do you do? Okay. So we also grow a lot of hanging baskets in the United States. With the hanging baskets, the way they grow is in a greenhouse. The hanging baskets, very rarely they occupy the floor or a bench. Most often the hanging baskets are hung to the roof of the greenhouse because they want to save the space. Plants are grown here, but then hanging baskets are hanging up there. Okay, it is a problem because they cause some shading, but they have figured out places like they'll have bench system, and in between benches they will have hanging baskets up there, so they won't cast any shadows on the plants on the benches. But there are lots and lots of hanging baskets. They get a lot of money for hanging baskets. Mostly hanging baskets, we grow annuals, petunias, creeping plants, geraniums. These are the type crops we grow. Sometimes even gerberas. Okay, but the problem with hanging baskets is what? If you're hanging up there, irrigation becomes even more difficult, right? So I have to now take a hose and I have to do like this, and I can't see it. Am I adding less water? Am I adding more water? I have no clue. So the irrigation of hanging baskets is a big problem. For that, they have come up with what we call ecosystem. Okay, what this ecosystem does is, you notice this, these are hanging baskets. These clamps here, these clamps are holding those hanging baskets, right? It's a clamp, black clamp, right? These clamps are connected to a string. Do you see that string right there? So they keep moving all the way to this wheel, and then they go back. Right around where this wheel is located, there is a spray station. So these four parts get watered. So the spray station is turned on. Water is falling like a sprinkler, right here. But these parts come there, get irrigated, then they go back. Every day they do that. They move the hanging baskets. That way, the biggest advantage with this is labor savings. You just turn on and they move like click, 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 one part at a time, and they get to this point and they get watered and then they go back. Every day we turn it on for some time. mechanical irrigation, automated mechanical irrigation. That's called eco irrigation, okay, for hanging baskets. In case if you want to, but that can cost you. Remember that can cost you. All of the mechanization is expensive. However, if you are in an area where labor is expensive, the mechanization will eventually become profitable, but it takes some time. It may take 5 years, it may take 10 years, but you will reap benefits of that. That's important, okay? All right, now let's go to sub irrigation. So those are, I talked about overhead irrigation. For those who came a little bit late, we are talking about irrigation. How do you irrigate, right? So there are two methods of irrigation. One, you add water top down. So water falls on the plants, runs down. That's overhead irrigation. The other method is bottom up. Okay, that's what I'm going to talk about. That's called sub irrigation. Okay. So here notice this is actually one of my many 2000 picture basically. I know this. These are wax begonias. Begonia is what I worked on during my master's when I was doing my MS program. But you see here what I was doing, I was trying to figure out what is the optimum fertilizer concentration in sub irrigation for these begonias. Now, before we dive into those details, I want to explain sub irrigation, and I also want to explain. Let me see if that is there in the next slide. If not, I will explain here. Yeah, let's get to that. I want to explain the theory behind sub irrigation. Okay, so slowly follow me. All right. So you have a tray. Okay, you have a tray here, and you have the small 4-inch pots sitting in the tray. This whole tray is sitting on a bench, and there is actually water. Do you see the water there? You can also see water here, right? All these trays are sitting in water. So the concept here is, when you put a pot with holes, and then when you run water, you create some, maybe this much height of water, that creates positive pressure, head, what we call head. Now, the substrate, remember yesterday we talked, it's got pores, right? There are a lot of pores, macropores, mesopores, micropores. The macropores, the pores are so wide, the water is always under the pressure of gravity, so water cannot climb up. One of you asked me the question, why water can climb in the meso and micropores. I said what? What was the reason? Capillarity, right? Surface tension, capillarity. This is exactly what is happening in sub irrigation. When you put the pot, some of these micro and mesopores, they come in contact with water, but at the bottom of the pot. And then now water starts wicking up, going up because of capillarity. Now let's say if I have this much water, but I have a tall pot, the water is not going to wick all the way up here. It's probably going to go a little bit higher, and that's it. So that's the most important thing I want you to remember. It is against gravity. It is because of capillarity, but there is a limit to it. Okay, you may use a 4-inch pot, or maybe this is 4 inches, that's like 10 centimeters, or you may go up to 6 inches, which is what, 15 centimeters or 18 centimeters, 15 centimeters. But you don't want to go beyond that, because as the pots become taller and taller, there will be more water at the bottom, and as the pots get taller and taller, less and less water, right at the top there won't be any water. It is against gravity, but it's going up. That is the mechanism of sub irrigation, capillarity, surface tension, and the water is going up. It's actually climbing in those meso and micropores. So now let's look at the benefits of this. There are many benefits of this system, and most of the benefits you notice kind of counter the disadvantages of the overhead system. The first and foremost benefit is this: the pot is only going to take the amount of water it needs. In overhead irrigation, you can apply too much water, because you'll put your hose on top of the pot and all the water is falling on substrate. You can add too much and waste the water. Here it is happening naturally. You are not causing the water to go up. It is because of the physical phenomenon, capillarity. So that substrate will only take whatever it can take. That's it. Let's say today you watered the pots through sub irrigation. the substrate got wet, moist, wet substrate. 1 hour later, let's say you come and again turn on sub-irrigation, the water will flow, but the substrate won't take it. Why? Because all those pores are already filled with water. There is no more wicking. It is not manual, it is through physical capillarity. So the nice thing about this is the plant substrate takes whatever it can, and you will never excess water the parts. That's one big advantage. You will never excess water the plants. Okay, it takes whatever. If it is a dry substrate, it takes a lot of water through sub-irrigation. If it is a wet substrate, it takes less water through sub-irrigation. But end of the day, all parts will have similar water content. Remember uniformity. Here is uniform situation, and you have done a uniform irrigation completely automatically, simply through using physics. The dry part will take more water, the wet part will take less water, but all parts end of the day will have similar amount of water. That is the benefit of sub-irrigation. Okay, so you don't add too much water, you don't waste water, you maintain uniform amount of water. Number one benefit. Any questions on that one? This is a very important benefit. Okay, number two benefit. I said in over irrigation, when you add water on the top, that water pushes all the fertilizer, right, outside, leaching. Is there any leaching here? Can water from the pot, fertilizers in the substrate, go away? The water is not going down, isn't it? What is the direction of water? It's going upwards. So there is no leaching at all. There is no leaching losses. You don't waste any fertilizer. This is a very good method of irrigation, especially to prevent environmental pollution. There is no leaching. There is no runoff of those fertilizer salts into lakes and ponds, because water is going up and it will stay in the pot all the time. But there is also a problem with that. If you fertilize every day with fertilizer water and all the fertilizer is going up and staying in the pot, at some point of time fertilizer starts accumulating. It can get too much. So what we recommend is every 15 days or so, we want to do a overhead irrigation and leach out that excess fertilizer salts, collect them somewhere else, but at least try to get rid of them. When you leach out, you are wasting fertilizer salts. So you can also avoid that by doing something else, and that's what I was trying to do here. The recommendation for sub-irrigation is, this is also very important thing. Rule of thumb is that in overhead irrigation, let's say your fertilizer concentration is some 150 ppm nitrogen, okay, approximately. The recommendation is 150 ppm nitrogen. That is for overhead irrigation. But when you get to sub-irrigation, we tell you to reduce it by half. Just use 75 ppm nitrogen if you are growing plants with sub-irrigation. Simply because there is no wastage, there is no leaching, and you don't want to keep on adding concentrated fertilizer. Plants will do perfectly fine even with half of the amount of fertilizer concentration. That tells us that in overhead irrigation, you are almost leaching out half of the fertilizer, isn't it? So many benefits: less wastage, uniformity, less fertilizer, all those things. Okay. So here is a commercial greenhouse. You see, there's a commercial greenhouse, and what are they doing? It's called flooded floor method, and this is called ebb and flow method. And I'll explain both of them. Let's talk about this flooded floor method. What they do is, if you go on any day to this greenhouse, just those trays of plants will be there on the floor. That's it. Nothing. The floors will be dry. But in the mornings, what they do is, they run the pumps, big pumps, and those pumps simply add water onto the floor. The floor is at a slight inclination. So the pump is on that side. So the water slowly flows down through the slope. But as the water is flowing, it creates a tiny head. It rises to this level. And that is enough for all of these parts to absorb water. You see, these are 6-inch parts, 15 centimeters deep. Is enough for all these parts to absorb water through sub-irrigation. Commercial ways, flooded floors. All you need is place them, make your floor little bit slope, so water runs down. Have big pump at the top, at that end, big pump, let the water run through and run it for 15-20 minutes every day, and your pots will absorb the water. They have created, you see here, a zone here. You see right there, there is a riser up there, so the water will not go up there. So this is a separate section. That's a separate section. That's a separate section. So there is a little bit of masonry, concrete work there, but that's it. You have created an irrigation method completely. No need of labor, nothing. You turn on. Initial investment is there a little bit on this concrete and creating a kind of like a slope here. But after that, there is no need for watering. You get all the benefits: uniform irrigation, less fertilizer, no leaching, things like that, all of that. Okay. With the ebb and flow system, what we do is we have trays, big trays. There are about the bench size, and you place parts inside. There is one pump that adds water. So you'll have a big reservoir at the bottom. So you have a pump, the pump adds water, the water is pumped for 15 minutes, so it raises to that height in the tray. During that time, parts absorb water, but then after 15 minutes, when you stop the pump, the water comes back to the reservoir. Recirculation, you can do that, ebb and flow system. Okay. I will talk about ebb and flow system again later on, but this is one method, this is another method. Both are sub-irrigation methods. Okay. Let's review sub-irrigation one more time. Yeah? Yes, everywhere.
Because water is coming from both the water will reach more to the edges, near the edges.
Right, but there are gaps between parts, and you create a pressure head, and you let the water stay for 15 to 20 minutes, sometimes 30 minutes. During that time, every part will get water. Every part will get water. You will actually see when you stand down and see, so the parts are kind of like there's that much gap between parts, and you can actually see that the water is rising between parts too. That is more than enough for the water to climb up. Yeah, there will not be any dry patches or anything like that. Okay.
It is kind of a modified method of that previous one. The first the method in the first division. Because we are in the first one we are just putting the water in the trays and the pots are absorbing that. In the second one we are creating a channel and then
Exactly.
the pots are
Exactly.
there
Exactly.
and there.
It's the same. It's for the commercial operations. If you don't want to invest on benches, all of that, you can just use a concrete floor and do that. That's the benefit of that. Benches can be expensive. Reservoirs and pumps can be expensive. Trays can be expensive, ebb and flow trays. To avoid all of that from ebb and flow system, you can simply create a concrete floor with a slope and create some edges and place your plants. You don't even need those trays, just place your plants on the floor. Create some gaps so water can flow in between nicely, and then they'll take the water. As simple as that. Okay, so let's review this quickly. Less wastage, recirculation and reuse is possible with sub-irrigation. Reduce the environmental issues because there is no leaching, no runoff, nothing. More uniform plant quality because your plants are, substrate is maintained at uniform water status, uniform fertilizer status, so plants are also going to grow very uniform. Less fertilizer requirement, as I told you, half of the concentration is all you need. But there are some problems here. Number one problem is this: if the water has pathogens, if that water that you're using in that big tank has some bacteria, things like that, you are sending that bacteria to each and every pot through sub-irrigation. So you got to be very, very careful, okay? So make sure that the water is not contaminated with bacteria or pathogens with sub-irrigation. The second thing is, actually I'll discuss this, fertilizer can build up, right? Because there is no leaching, so I told you what should you do? You should top over irrigate the plants to get the excess salts go away sometime. And it can be a little bit more expensive. I don't know why it went here. Let's see. All right. So that's overhead irrigation and sub irrigation. Two things. Those are the characteristics, benefits, advantages. You saw some real pictures of how these irrigation systems work. The things like boom system, the echo irrigation for hanging pots, or the sub irrigation probably are new. But these are the kind of things you may want to explore, especially if you are a startup, right? And you want to see the benefits rather than sticking to the norm. Oh, they have done that, I'm going to do that. Then you are going to simply inherit what they have done you're going to simply inherit all the problems what the system has. But if you try to explore new things, you may learn new, it may fit to your situation. So be bold and courageous if you are especially a young entrepreneur. Explore things. These are all the technologies that other people have used. Okay, so you know what is out there. All right. After the irrigation methods, what I want to tell you is, how do you irrigate? How do you know when to irrigate? Right? There are 3 methods to know when to irrigate. This is a very important question. People almost always make a mistake here on when to irrigate, because most often they follow what? A timer. What does a timer based irrigation mean? The timer based irrigation means every day in the morning, 9 o'clock, turn the pump on automatically. We call it automated irrigation. Yeah, it's a nice term, fancy term, but there is a big problem there. Do you know if plants need water that day? Maybe they don't, but still water is turned on because it's automated. The automation does not know if the plants need water or not, or if the substrate is moist or dry. Simply it comes on. I will give you a very funny example. I have seen it many times in the US. We have big lawns in front of houses, right? Every house has a lawn in the front, in the back. We do mowing and keep the houses clean. But all these lawns have automated irrigation, sprinkler systems. Okay. So now I'm here in the US. I have turned on my sprinkler system in my house, right? So every Tuesday, every Thursday, and every Saturday, the sprinkler comes on and irrigates my lawn. But I know, I'm seeing in my video, that it is raining every other day there. So no matter if it is rain or not, the sprinkler is coming and I'm wasting water. What can I do? I can't do anything. It's set on a timer, that's it. That's the problem with, this is just an example, this is a problem with the timer system. So remember that. So then there is a slightly improved method. The improved method is, now you want to measure how much water is there in the substrate. Rather than on a timer, let's measure substrate water, and when the substrate water content is less, then add water. You can also do automation. This was my PhD way back. Basically what I did was, I created an irrigation controller using data loggers, and later on, next week, I will show you an example. In fact, I asked one of my PhD students to call in on Zoom from US and show an automated system for you, so you can see. I couldn't bring it here, but he can do it from there, so we can see it at least. I think he's not going to do an automated irrigation system, but he's probably going to show an automated lighting system, because it's simple. He can sit inside the lab and do it. For irrigation, all the water will fall in the lab, so I just told him try to do a lighting system, but it's the same way. What you can do is, in this case, you'll use sensors. Volumetric water content sensors. Yesterday we learned about volumetric water content, isn't it? Who can define volumetric water content? Who remembers that equation? Volumetric water content. We did the calculation also. Remember, I draw a pot. So what was the numerator? What was the denominator? Exactly. Volume of water by volume of. So that is volumetric water content. That is what you measure manually. You weigh the parts, you weigh the amount of water and everything, and then you calculate it. But there are sensors. Next slide I'm going to show you. These sensors, when you put them inside, they'll give you a measurement quickly, like in 1 second. 35% water, 55% water. So you have to use those sensors, and you can connect those sensors to your automation system. Now, the automation is not dependent on a time. Now the automation is now dependent on what the sensor tells the controller. The controller is continuously measuring the sensor, and whenever the controller finds that the sensor numbers are lower than what you want to maintain, then it turns on the irrigation. That is called sensor based automation. That's a lot improvement over timer system. At least now you know that substrate is dry, so you should add water. The third, which is the best method and also most complicated method, is based on plants, not on substrate, but based on plants. Sometimes the sensor may say, oh, there is 40% water, and you may have set a target that whenever it is above 45, add water. But maybe that 40% is enough for plants. Maybe these plants are small, or maybe that is not enough. End of the day, what matters is what plants want, not what is there in the substrate, not what the timer is telling, right? So this is the most accurate method. The third method is plant-based systems. And I'm going to show you an example on how to do that too with some pictures. Okay. So there are three ways you can determine when to add water. Okay. How much is another question. How much is all? It depends on species. There are drought tolerant species, there are sensitive species, but rule of thumb, as long as you maintain container capacity, I think most of the plants will be happy. You know what container capacity is, right? After the drainage, after the macropores drain, whatever that water is left over, that's called container capacity. I gave you a table yesterday afternoon. You can determine the container capacity yourself for your own substrate using the table, right? Best method is to maintain container capacity, rule of thumb. But now let's talk about these two methods, substrate water status, what are those sensors, and what are these plant water status sensors, two types of sensors. And that's the last two slides for this topic, okay. So here are two sensors that we commonly use. These sensors measure volumetric water content, okay. These are about $200 each. This is $200, that's maybe $400, okay. These sensors, you can connect them to a handheld device and you can press a button, put the sensor in the pot and see the value. Or you can also connect the sensor to a controller, an irrigation controller. The irrigation controller gets the data from the sensor and then turns on or off irrigation based on that, okay. I have put some description here for you on how these sensors work. You don't need to learn about it unless you are interested. You are the kind of guy, I want to know the theory, all of that, do read it, but not necessary. This is called a dielectric sensor. This is called a reflectometer. Both of the sensors use light, electromagnetic propagation, okay. And there is a description, nice description here. In case you are interested, you can read it, but if you are not interested, at least see these sensors. These two are two rods. So this sensor is about what? Just 5 centimeters. That much tall. That's all. You take the sensor and you put it in a pot and you get a number right there. This will give you three types of data. One, it will tell you how much water is there. It will tell you how much fertilizer is there. And it will also tell you the temperature of the soil. All those three things you can get from that sensor. Same thing here too, okay? Same thing here. Here these rods can be 10 centimeters, a little bit longer too. In case if you want to put it in soil, let's say you have a raised bed and you are growing roses or you are growing tomatoes on raised beds. You want to insert deeper, so you can go for these sensors too, okay? These are called volumetric water content sensors. They measure water content, volumetric water content, okay? Now let's go and look at plant-based sensors. All right, so you can actually, if you're interested, they sell now, this company, FLIR, this company sells tiny thermal cameras that you connect to your phone, okay, you can insert it right here. It's a tiny thermal camera. I wish I brought it with me. I took these pictures with that. I'll explain what's going on, but you can connect to your phone and you can take a picture of the plant, okay. Remember transpiration? Why do plants transpire? To maintain the temperature. When transpiration is less, what happens then? Leaves get warmer, right? If they transpire, they are cooler. If they don't transpire, they get warmer, right? So, if the leaves are warmer, what does that mean? They are transpiring less. When will they transpire less? When there is less water. So now you are not depending on the timer, you are not depending on how much water is in the substrate, you are literally talking to the plants in a separate language though, but you are really seeing what's going on to the plants and then you are adding water. See, here's an example here. This is the same plant, same set of plants. These both pictures are from the same plant. This was taken before irrigation, this was taken after irrigation. Look at this scale at the top. White, yellow colors are, what is the temperature? 38 degrees Celsius. When you get to purple and dark blues, what is the temperature? 20 degrees Celsius. So this picture, you got some purples here and there, but lot of yellows, and right? And then we added water, and then what has happened here? And what purple means? Leaves are? Why are leaves cooler? There is a lot of water now in the pots, right? So this is plant-based method. This is thermal cameras, and nowadays all kinds of thermal cameras are there. In fact, this January, when I come here for my Fulbright Scholar, I'm bringing in some of the thermal cameras that we prepared in our lab, and we are actually using these thermal cameras to determine when to add water to tomato plants, or maybe pepper plants too, okay? So we want to save water that way. We want to only add water when plants want water, not when the soil is telling or not when the timer is telling. And when we do that, you get the maximum benefit. You will save water. You will also provide water in the optimum way so the growth is maximum. We're also bringing some sensors that measure nitrogen also in the plants. So we'll also kind of modify when to fertilize plants. So when to water, when to fertilize. That's my goal, but using digital technology, using camera-based systems, using image analysis, using Internet of Things, IoT systems, right? But that's a different story. But here is an example for you, the benefit of that. Now you can see actually what is happening to the plants, okay? That's my last slide. So this is about irrigation, totally applied. What are the different irrigation methods? What are the pros and cons of overhead and sub-irrigation? What are the benefits, mostly important benefits from sub-irrigation? You should know that. Then we looked at irrigation, when to irrigate. Should you irrigate based on timer, advantages, disadvantages? Should you irrigate based on sensor? What sensors are there? Soil moisture sensors. And then finally plant-based irrigation using thermography, infrared cameras. Okay. All right. Did you learn something new today? Something new today? Okay, good. All right. So I know this is continuous. We have time until I guess 11 o'clock. So is everybody okay for me to go on, or do you want a few 5 minutes bio break or something like that? Do you want a break? Just 5-minute break. Okay. Just grab some water and come back, please.